Have you ever wondered if people back then discovered things about the Earth and the universe before the revolution of technology? Perhaps if we think and go back to the ancient times, we would most likely be captured by their beliefs and practices. Will you pause for a moment and think if they thought about the Earth and the universe like how our contemporary scientists, astronomers, cosmologists, and so forth invest most of their time in discovering using technology? Let's start with the Earth's circumference. Meet this man. He is named Eratosthenes. Did you know that he measured the Earth's circumference by using only two things? His brain and his dick, excluding any technology. Eratosthenes of Cyrene. He's a Greek scientific writer, astronomer, and poet who made the first measurement of the size of the Earth. Eratosthenes was fascinated with geography and planned to make a map of the entire world. He is the father of geography. Eratosthenes measured Earth's circumference mathematically using two surface points to make the calculation. He noted that the sun's rays fell vertically at noon in Syene at the summer solstice. At noon in the summer solstice, Eratosthenes measured the length of the shadow cast by a column of known height at Alexandria. And now, the early models of the universe. Eudoxus of Cnidus. He's a Greek mathematician and astronomer whose substantially advanced proportion theory contributed to the identification of constellations. Eudoxus was the most renowned astronomer and mathematician of his day. In astronomy, devised an ingenious planetary system based on spheres. The spherical Earth is at rest at the center. Around this center, 27 concentric spheres rotate. Eudoxus' model placed a spherical Earth at the center of the universe. The Sun, planets, and stars were then placed in giant transparent spheres surrounding it. His model is a geocentric model of the universe. Aristotle. Aristotle is an ancient Greek philosopher and scientist, one of the greatest intellectual figures of Western history. Aristotle's own model of the universe was a development of that of Eudoxus, who had also studied under Plato. It had a series of 53 concentric, crystalline, transparent spheres rotating on different axes. Each sphere was centered on a stationary Earth, so the model was both geocentric and homocentric. Aristarchus of Samos. He's an ancient Greek astronomer and mathematician who presented the first known heliocentric model that placed the Sun at the center of the known universe, with the Earth revolving around the Sun once a year and rotating about its axis once a day. Aristarchus was one of the first astronomers to calculate the relative sizes of the Sun, the Moon, and the Earth. He did this by observing the Moon during a lunar eclipse and by estimating the angle and the size of the Earth. He visualized that the Moon orbits around a spherical Earth which then revolves around the Sun. He believed that the stars are very far away from the Earth, as evidenced by the absence of stellar parallax. That is, the stars do not change positions relative to each other as the Earth revolves around the Sun. Plato. Plato is an ancient Greek philosopher born in Athens during the classical period in ancient Greece. He's an Athenian and a pupil of Socrates. Plato had a profound influence in philosophy and he wrote widely on many different fields. To Plato, the universe was perfect and unchanging. Stars were eternal and divine, embedded in an outer sphere. All heavenly motions were circular or spherical as the sphere was the perfect shape. The same with Aristotle. Plato proposed the geocentric model of the universe, claiming that the Earth was the center of the universe and all the planets and the stars revolved around us in concentric circles. For him, the universe consists of crystalline spheres containing Moon, Sun, and the stars, or the celestial sphere. Pythagoras. Pythagoras is one of the most famous and controversial ancient Greek philosophers and mathematician. He is the first ancient astronomer to suggest that there was a harmony of the spheres and that the movement of the planets, sun, moon, and stars could be described by whole numbers and mathematical precision. His other discovery was that the morning and evening star are the same thing, the planet Venus. Claudius Ptolemy, an Egyptian astronomer, mathematician, and geographer of Greek descent who flourished in Alexandria during the 2nd century CE. In several fields, his writings represent the culminating achievement of Greco-Roman science, particularly his geocentric model of the universe, now known as the Ptolemaic system. Ptolemy recorded longitudes and latitudes in degrees for roughly 8,000 locations on his world map, giving a detailed image of the inhabited world as it was known to a resident of the Roman Empire at its height. Based on observations he made with his naked eye, Ptolemy saw the universe as a set of nested, transparent spheres with Earth in the center. He posited that the Moon, Mercury, Venus, and the Sun all revolved around Earth. Nicolaus Copernicus is a Polish astronomer who put forth the theory that the Sun is at rest near the center of the universe, and that the Earth, spinning on its axis once daily, revolves annually around the Sun. This is called the heliocentric or sun-centered system. He reintroduced the idea of a heliocentric universe in On the Revolutions of the Celestial Spheres, first published in 1543, which was considered as the most important book ever published in the field of astronomy. Copernicus solved the problem of retrograde motion. Nonetheless, his theory did not immediately replace Ptolemy's theory. Tycho Brahe, a Danish astronomer who made some of the most accurate ever observations with the naked eye in the late 16th century. He disproved Aristotle's concept of an unchanging universe when he saw a new star in the constellation of Cassiopeia in 1572. This was later identified as a supernova. Tycho also proved that Aristotle's transparent spheres do not exist by showing that comets would have to travel through them. He favored an Earth-centered universe different from Ptolemy's theory. He thought that other planets revolved around the Sun and that the Sun and Moon revolved around Earth. His theory was incorrect, but made many precise observations of planets and stars. Johannes Kepler is a German astronomer, mathematician, astrologer, natural philosopher, and writer on music. He is Tycho's assistant and used Brahe's observational data to develop laws of planetary motion. The three laws of planetary motions are law of ellipses, law of equal areas, and law of periods. Kepler's first law states that the orbit of every planet is an ellipse with the Sun at one of the two foci. Kepler's second law states a line joining a planet and the Sun sweeps out equal areas during equal intervals of time. And lastly, Kepler's third law states that the square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of its orbit. By 1619, Kepler was able to determine the relationship between a planet's average distance from the Sun and the time it takes to complete one orbit, its period. While this did not allow him to calculate the actual speed or distance of each planet, he could work out the relative speeds and distances. Kepler showed that the Earth travels around the Sun at a faster speed than Mars, which explains the apparent ellipse in Mars' orbit. Galileo Galilei. Galileo was a natural philosopher, astronomer, and mathematician who made fundamental contributions to the sciences of motion, astronomy, and strength of materials and to the development of the scientific method. He also made revolutionary telescopic discoveries, including the 4 largest moons of Jupiter. Galileo favored Copernicus' theory rather than Ptolemy's, and he was the first person to use telescope for astronomical observations. Some of his discoveries are the following: Galilean satellites, craters on the Moon, sunspots on the Sun, and phases of Venus. Isaac Newton is an English physicist and mathematician who was the culminating figure of the scientific revolution of the 17th century. Newton was one of the first to make a reflecting telescope. However, his most profound contribution to science is the formulation of 3 laws of motion, described in Philosophia Naturalis Principia Mathematica in 1687, which also lays the foundation for the principle of universal gravitation. Isaac explained why planets orbit the Sun and why moons orbit planets, as he was able to develop the basic law of motion and the law of gravitation. He was the one who completed the work of Copernicus, Kepler, Tycho, and Galileo.